In this video, we're going to talk about simplifying rational expressions. A rational function is a function that is the ratio of two polynomials. More casually speaking, it looks like a fraction where the numerator and denominator are both polynomials. Restrictions are values of the variables in a rational function or rational expression that cause the function to be undefined. These are the zeros of the denominator, or equivalently, the numbers that are not in the domain of the function. Often we simplify a rational expression by factoring both the numerator and denominator and crossing out like factors. Then we state restrictions by following these steps. Let each factor of the denominator equal 0. Solve for the variable, and then state that the variable cannot equal those values. The variable cannot equal the value that makes a factor of the denominator equal 0, because that would make the denominator equal 0, and denominators cannot equal 0. We can't divide by 0 in math. So that's what it means to be a restriction. So suppose we wanted to simplify the rational expression shown. What we could do is simply factor 6 out of the numerator and factor 3 out of the denominator. Then we would see an opportunity to cross out the 6 with the 3. We'd be left with a 2 up top and a 1 down below. And so we'd be able to say that the answer is 2 times a minus 2 over 1 times a, or in other words, just 2a minus 4 over a. And then we would have to state what value of a would make that denominator equal 0, and the answer is 0. So we'd have to say that a cannot equal 0. So that's shown here a little bit more neatly. Now in this example, instead of factoring out 6, I sort of recognize right away I'll only be able to cross out the 3. So I factor a 3 out, leaving me with 2a minus 4. And then I have 3 times a in the denominator. And I'm left with an answer of 2a minus 4, but we still have to state restrictions. The only factor in the denominator is a, so we let that denominator equal 0, see that that would mean that a was equal to 0, and then say we cannot let that happen. Therefore, the restriction is a cannot equal 0. Okay. So what if we have the expression shown? Well, we recognize an opportunity to factor out 5x from the numerator. And that's the same as saying 5 times x. And then we still have the binomial remaining. In the denominator, 10x can be thought of as 2 times 5 times x. And this lets us cross out the 5, the factor of 5 in both numerator and denominator, as well as the factor of x in both numerator and denominator, leaving us with simply xy minus y squared over 2. Now, you don't have to show the single term factors being factored into smaller factors when you simplify the way that I have here. You might just be able to, you have to come up with the same final answer, but if you don't actually show them being broken apart but are able to do that division, that'll be fine. So what I mean is if you simply left it as 5x and then xy minus y squared, and then down below you had 10x, and you were able to simply show that the 5 and the 10 leaves you with a 2 down below. And if you were able to do all that in your head, that would be fine. But the point being, you have to come up with xy minus y squared all over 2. Now, one thing I'd like to point out is you might be saying, well, wait a second, it should say y times x minus y all over 2. That's fine if you show that. It's not necessary, but if you do factor out that numerator, that's fine. But what I do want to show you is that what's left is, after we have this red answer that I'm circling again, xy minus y squared over 2, after we're left with that, we still have to state restrictions. It's tempting to say there will be no restrictions because there are no variables in the denominator. There's no value of the variable that could make 2 equal 0. It's not quite that easy though, because you have to look back at any factor of the denominator that was ever there. So if you look back at this denominator, even though I've crossed out these factors, at one point we had 2 times 5 times x in the denominator. There's certainly no value of x that would make 2 equal 0, and there's certainly no value of x that would make 5 equal 0. But there is a value of x that would make x equal 0. And that value is 0 itself. So we have to say x cannot equal 0, otherwise a factor of the denominator would equal 0. So we have to state the restriction x cannot equal 0. And if you're thinking, yeah, but we crossed it out, it doesn't matter. Even if you cross out a factor of a denominator, you still include that when you talk about restrictions. So our final answer will simply be xy minus y squared over 2, and x cannot equal 0. Or if you prefer, you can call it y times x minus y all over 2, x cannot equal 0. Either answer is acceptable. Now, what if we have the rational expression shown? Well, we see here an opportunity in the numerator, first to common factor out of 5, and in the denominator to common factor out of 3. Then we see an opportunity to do complex trinomial factoring in the numerator and complex trinomial factoring in the denominator. And we're left with this expression right here, 5 times x plus 2 over 3 times x plus 4. Now, we have to say that 2x minus 3 was at one time a factor of the denominator. We cannot let that equal 0. So therefore, we cannot let 2x minus 3 equal 0, meaning 2x cannot equal 3, meaning x cannot equal 3 halves. And similarly, x plus 4 is a factor of the denominator. We cannot let that equal 0, meaning x cannot equal negative 4. We have two restrictions. Sometimes a student is tempted to say, oh, but also x plus 2 cannot equal 0, so x cannot equal negative 2. This is wrong. X can equal negative 2. It's okay for a factor of the numerator to equal 0. It's not okay for a factor of the denominator to equal 0. Okay? Now, if we wanted to state the domain of that function, the answer would simply be any real number with the exception of those two restrictions. Now, what if we wanted to simplify the rational expression shown? Well, we have an opportunity for complex trinomial factoring. And so we factor the first trinomial into x minus 4y times x plus 3y, the second trinomial into x plus 5y times x minus 4y. We can cross out the x minus 4y's and we're left with the expression shown, x plus 3y over x plus 5y. We know that x plus 5y cannot equal 0, meaning x cannot equal negative 5y. We know that x minus 4y cannot equal 0, meaning x cannot equal 4y. And we have our restrictions. Again, we do not say x plus 3y can't equal 0 because x plus 3y can equal 0. It's in the numerator. For each value for each of those factors in the denominator, when we have two different variables like we do here, usually what we'll do is we'll pick one variable and state the restriction in terms of that variable. So regarding the factor x plus 5y, we'll either state x cannot equal negative 5y, or if we prefer to divide both of those, both left and right of that restriction by negative 5, we can say y cannot equal negative 1/5 x. But don't state both. Okay? And so our final answer to this question is the expression x plus 3y over the expression x plus 5y, such that x cannot equal negative 5y or 4y. Now, what if we're given the rational expression 2m minus 3n over 3n minus 2m? Our instincts might tell us there's an opportunity here, but I can't see quite what. Sometimes what a person can do in a situation like this is try switching the signs of either the numerator or denominator. The way that works is you factor out a factor of negative 1. If you factor a factor of negative 1 out of the numerator, you'll be left with negative 2m plus 3n in the numerator. Okay, factoring a negative 1 out of there leaves you with negative 2m plus 3n. Well, negative 2m plus 3n is the same as 3n minus 2m. Well, at that point, we say that's a factor of both numerator and denominator, so we can cross those factors out. And we're literally left with negative 1 up top, positive 1 down below. Negative 1 over 1 is negative 1. And so our final answer is negative 1. Now, we then go to state our restriction. The only factor of the denominator that contains variables is 3n minus 2m. We cannot let that equal 0. Adding 2m to both sides means 3n cannot equal 2m. Dividing both sides by 3 means n cannot equal 2/3 m. So if asked to simplify this, we would say the answer is -1, such that n cannot equal 2/3 m.